Welcome to my channel Divyas Maths.
We will see properties of subset. Okay, so the first property is null set is a subset of every set. So when you are writing subset for a given set, okay, so null set will be the subset for the every set. The next one is every set is a subset of itself. So if you have set A, that is 1, 2, 3. Yes, so we can say that A is a subset of A. Yes, in the same, if you have B is equals to 1, 2, 3, 4. We can say that B is a subset of B. Yes, so every set is a subset of itself. If A is a subset of B, B is a subset of C, then A is a subset of C. Example, A is equals to 1, 2, 3. B is equals to 1, 2, 3, 4. C is equals to 1, 2, 3, 4, 5. If you see, all the elements in A are also elements of B. So we can say A is a subset of B. Yes, and all the elements of B are also an elements of C. So B is a subset of C. Yes, then we can say that A is also a subset of C, because all the elements in A are also subset of C. Now we will see writing the subsets for any given set. So let's take A is equals to 1, 2, 3. Now let's write a subsets for this set. Okay, subsets is equals to. So we have seen the properties of subsets, right? So what is the first property we have seen? That is null set is a subset to every set. So let's start with a null set. Okay, after writing a null set, I will take a individual element first. Okay, 1, 2, because 1 belongs to A, right? We have a element 1 in a set A. So set 1 is a subset of A. We are taking single elements to write the subsets. 1, 2, 3. Once we are completed single elements, we'll go with the two elements. 1, 2 belongs to set A. After 1, 2, I will take 1 and 3. 2 and 3. 1, 2, 3. Okay, so how many subsets did you get? 1, 2, 3, 4, 5, 6, 7, 8. You got 8 subsets. So you have a formula for writing the subsets, that is number of subsets is equals to 2 power n, where n is equals to number of elements in a set. Number of elements in a set. If you take this set, you have how many elements? 3 elements, right? So 2 power 3, that is 8, which is matching to the subsets we have got. Now let's take other example. So find subsets of P is equals to X, Y, Z, Z. Now let's write subsets is equals to. So what is the formula for that? Number of subsets is equals to 2 power n, where n is equals to number of elements. Correct? So 2 power, how many elements we have? 4 elements. So 2 power 4 is equals to 16. For writing the subsets, first property is null set. So I am taking a null set. Then I am taking a individual element x, y, z, w. Okay, then I'll take 2 elements x, y, x, z, x, w, then y, z, y, w, then z, w. Okay, once I complete all the 2 elements x, y, x, z, x, w, y, z, y, w and z, w, I'll take 3 elements x, y, z, x, y, w, y, z, w, x, z, w. So once we complete 3 elements, I'll take all the 4 elements because every set is a subset of itself. Okay. Now let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have got 16 subsets which is matching to our formula. Yes, so it is right. The next topic is basic operations of sets. The first one is union of sets. So what is union of sets? The union of 2 or more sets is the union of all the elements. It is represented as A union B. So if you have set A is 1, 2, 3, 4. Set B is equals to 3, 4, 5, 6. A union B is equals to, what is A? 1, 2, 3, 4. Union B is 3, 4, 5, 6. What is union? All the elements from both the sets. 1, 2, 3, 4. In set B, 3, 4 is already present in set A. So we are not repeating the elements. So I am just taking 5, 6. So this is A union B. This is in the roster form. Now let's write in the set builder form. Set builder form for the A union B. X such that X belongs to A or X belongs to B. Now let us represent it in a Venn diagram. This is your universal set. It is represented by a rectangular box, mu. This is your set A and this is set B. So set A and set B have a common elements 3 and 4. So I am writing 3 and 4 common elements. Apart from 3 and 4, A has 1 and 2. So I am writing 1 and 2 here. B has 5 and 6, right? So I am writing 5 and 6. So A union B is all the elements from both the sets. So I am shading all the elements from both the sets. So this is A union B. The next one is intersection of sets. If two sets A and B are given, intersection is the set of all those elements which belong to both A and B. It is written as A intersection B. Okay. So if you have elements set A as 3, 4, 5, 6, set B as 5, 6, 7, 8. We need to find A intersection B. Right? So what is set A? 3, 4, 5, 6. Intersection set B 5, 6, 7, 8. Right? Intersection is nothing but your common elements from both the sets. That is, what are the common elements from both the sets? 5 and 6. Okay. So you need to take the common elements from both the sets. This is your roster form. Yes. Now let's write the set builder form. Set builder form for the A intersection B. That will be X such that X belongs to A and X belongs to B. As it is a common elements, it should belong to both the sets A and B. Yes? Now let's see the Venn diagram. How do we represent A intersection B using a Venn diagram? This is your universal set. This is A. This is B. A and B have a common elements 5 and 6. Yes, other than 5 and 6, A has 3 and 4, B has 7 and 8. So we need to shade the common elements because we are taking common elements. This is A intersection B. The next one is difference. Difference of sets. If two sets A and B are given, difference is the set of elements which belongs to A but do not belong to B. A minus B. So if you have A is equals to 6, 7, 8, 9. B is equals to 8, 9, 10. What is A minus B? 6, 7, 8, 9 minus 8, 9, 10. Difference is nothing but a set which belongs to set A and does not belongs to set B. Okay, we will only consider set A. So if you have any common elements in set A and set B, you will cancel those elements and take the remaining elements of only set A, which is 6 and 7. This is your A minus B. So this is in the roster form, right? So how do we write it in the set builder form? For A minus B, X such that X belongs to A and X does not belongs to B. How do we represent in the Venn diagram? So this is your universal set. Yes. This is A and this is B. A has 6, 7, common 8 and 9. This is 10. But we will only take the elements of A. We will not even consider the common elements and the elements of B as well. Yes, this is A minus B. So how do you do it for B minus A? Let's see that. B minus A. So what is B? 8, 9, 10. Yes, minus what is A? 6, 7, 8, 9. Yes, so you will consider only the elements of B and cancel all the elements which are in common. Okay, so let's cancel the elements first which are in common and only consider the elements of B, that is 10. Okay, this is your B minus A. This is your roster form. Now write the set builder form for this. Set builder form for B minus A. X such that X does not belong to A. We are not considering the elements of A, right? And X belongs to B. This is for B minus A. And what about the Venn diagram? Venn diagram. So this is the universal set. This is the A and this is B. A has common 8 and 9, 6, 7 and 10. But we will only consider B. Yes, we will not consider the common part as well. Yes, this is for B minus A. Okay, the next one is disjoint sets. Consider A and B are two finite sets. If there are no common elements in both A and B, such set is known as disjoint sets. So, for example, if set A has 1, 2, 3 and if set B has 4, 5, 6. Okay, so if you want to find common elements, what will you do? You will do A intersection B, right? So what is A intersection B? What is A? 1, 2, 3 intersection. What is B? 4, 5, 6. So do we have any common elements? No, right? That is your null set. Yes. So if A intersection B is your null set, then it is said to be disjoint sets. Okay. Next we will see fundamental theorem on sets. So n of A union B is equals to n of A plus n of B minus n of A intersection B. Okay, and the next, if you want to find n of A intersection B, that will be n of A intersection B is equals to n of A plus n of B minus n of A union B. These both are important formulas of the fundamental theorem on sets. So we will take an example. A is equals to 1, 2, 3, 4, 5. B is equals to 2, 4, 6, 8. Then show that n of A union B is equals to n of A plus n of B minus n of A intersection B. So A is equals to 1, 2, 3, 4, 5. Yes, you can count the number of elements. Then it is a finite set. So what is the cardinal number of this set? N of A will be 5. Yes. So B is equals to 2, 4, 6, 8. So how many elements you have in a set? 4. So N of B, what is the cardinal number for this? 4. Correct? Then you need to find A union B. So A union B is equals to, what is A? 1, 2, 3, 4, 5. Union 2, 4, 6, 8 is your B. So what is A union B? All the elements from both the sets, right? So I will not repeat the elements of the set. Yes. So these are the elements of A union B. If I want to find N of A union B, how many elements do I have in a set? There are 7 elements, right? So the cardinal number will be 7. In the same way, if I want to find N of A intersection B, so 1, 2, 3, 4, 5 intersection 2, 4, 6, 8. That is the common elements from both the sets. What are the common elements? 2 and 4 are the common elements. 2 and 4. So, if you want to find N of A intersection B, there are 2 elements, so the cardinal number will be 2. So, we need to show that N of A union B is equals to N of A plus N of B minus N of A intersection B. So we have N of A union B is 7, N of A is 5, N of B is 4, N of A intersection B is 2. Yes. Now let's see, N of A union B is 7 is equals to 5 plus 4 minus 2. That is 7 is equals to 7. Hence proved. Yes. So we have proved that N of A union B is equals to N of A plus N of B minus N of A intersection B. Clear?
In our next video, we will solve few exercise problems on sets. If you have any doubts, please put them in the comment section below so that I can respond to them.